All right, let's talk about something that I'm sure every single person working in the cloud has felt. That sprawling, spiraling complexity. Today, we're going to dive into how a seriously powerful tool, Terraform, can help us tame that beast and bring some sanity back into our lives.
So, does this sound painfully familiar? You're in the cloud console, you're clicking away, you set up a server here, a database there, maybe you tweak some network roles. Then you fast forward 6 months. Does anyone on your team remember exactly how that thing was configured? Yeah, I didn't think so. It's a world of click ops, and honestly, it's just a recipe for chaos.
But what if you could manage the entire shebang with simple, repeatable code? I mean, that's the real game changer right there. Instead of clicking, you're writing. You're creating code that you can version, review with your teammates, and fully automate. This whole approach is called infrastructure as code, or IAC for short. And trust me, it changes everything.
Okay, so let's get right into it. Section 1, moving from that cloud chaos to clean, manageable code. So what is infrastructure as code really? Well, at its heart, it's about treating your infrastructure, your servers, databases, networks, all of it, the exact same way you treat your application code. You define it all in files, you check it into version control like Git, and you collaborate on it as a team. The whole point is to make your infrastructure totally predictable and, you guessed it, reproducible. And this is where Terraform enters the picture. It's one of the biggest names in the IAC game for a reason. What you're seeing here is the core magic. You, the user, write these simple, human-readable config files. And then Terraform, this powerful engine, takes those files and figures out how to make it a reality on pretty much any cloud provider out there. AWS, Azure, Google Cloud, you name it. You just tell it what you want, and Terraform takes care of the how.
All right, so how does this actually work day to day? Let's look at Terraform's core workflow. It's a super simple but incredibly powerful 3-step dance that you're going to do over and over and over again.
And this diagram, it just perfectly sums it up. It all boils down to 3 words: write, plan, and apply. This loop you see here, this is the absolute heartbeat of Terraform. It's what makes the whole process so safe and predictable.
So let's break that down. First, you write. You define what you want in those simple TF files. Then, and this is the most crucial part, you plan. You run a command, Terraform plan, and it gives you a preview. This is your safety net. It tells you exactly what's going to be created, what will be updated, or even what will be destroyed. No more surprises. And only when you've reviewed that plan and you're happy with it, do you move to the final step, apply. You give it the green light and Terraform makes it all happen. Okay, so you're writing code, but let's be real, putting everything into one single giant file is gonna get messy, fast. So how do the pros handle this? Well, they use something called modules. And you can just think of them as infrastructure Legos.
I mean, just look at the difference here. On one side, you've got this monolithic beast. One massive file that's a nightmare to read, a pain to reuse, and honestly pretty risky when you have a whole team working on it. But on the other side, you have modular code. Nice, clean, self-contained packages. Each one does a specific thing. This isn't just a preference, it is the professional standard for a reason. It's clean, reusable, and so much safer for teams. I absolutely love this quote from HashiCorp's own guide because it just nails the concept. Modules should be opinionated and designed to do one thing well. It's that Lego brick idea, right? Each brick has a specific purpose. You don't try to make one brick do everything. You grab the bricks you need, snap them together, and build something amazing and complex out of simple, reliable parts. So the big question is, how do you decide what goes into one of those Lego bricks? Well, there are some really solid guidelines. Think about encapsulation. If you always deploy a web server with its security group, bundle them together. Think about privileges. Maybe the networking team owns the core network modules and app teams own the app server modules. And finally, volatility. And this one's huge. You want to separate stuff that rarely changes, like your core network, from stuff that might change every single day, like the servers running your application.
Okay, time to talk about something that is absolutely critical and honestly a little misunderstood sometimes. The state file. You can think of this as Terraform's brain, or its memory. So what is it? The Terraform state file is basically a big map. It's Terraform's source of truth. It connects the resources you've defined in your code to the actual real-world resources running out there in the cloud. Without this file, Terraform would have amnesia. It wouldn't have a clue what it's supposed to be managing. Now here's the catch. by default, Terraform just drops this state file right onto your computer. And for anything beyond a small personal project, this is a terrible idea. Seriously. First, it's a huge blocker for teamwork. Second, it can contain sensitive data like passwords in plain text. Yikes. And third, what happens if your laptop dies or you accidentally delete the file? Poof, you've just lost the entire map to your cloud kingdom. The only real solution here is what we call remote state. Instead of your laptop, you tell Terraform to store that state file in a secure shared location, like Azure Storage or Amazon S3. This immediately unlocks team collaboration, adds locking so two people can't make changes at the same time, and it's way more secure. For any professional team, this isn't just a nice to have, it is absolutely essential. Okay, so we've got our code neatly organized into modules. We have our state files stored safely in a remote location. Now, let's bring it all home. Let's talk about automating this whole process in a secure deployment pipeline. This is what a modern professional workflow looks like. A developer pushes their code, which automatically kicks off a CI/CD pipeline. That pipeline runs a Terraform plan and posts the output right into a pull request for the whole team to review. Everyone can see exactly what's about to change. Then, once it gets the thumbs up, the pipeline merges the code and automatically runs Terraform apply. It's hands-off, it's repeatable, and everything is fully audited.
But of course, with great automation comes great responsibility, right? We need guardrails. And the beauty is we can build security right into that pipeline. We can use policy as code to automatically enforce company rules. We can run static code analysis to scan for misconfigurations before they're deployed. We can pull secrets from a secure vault instead of hard-coding them. And we can use role-based access control to make sure the pipeline has only the minimum permissions it needs. It's security automated.
Whew, we've gone from chaos to code to a fully automated secure pipeline. So let's wrap this up with a clear blueprint for what this all looks like when it comes together. All right, here it is, your professional Terraform checklist. 1. Define everything as code. 2. Structure that code with reusable modules. Think Legos. 3. Use remote state with locking. It's non-negotiable for teams. 4. Automate your deployments with a CI/CD pipeline. And 5, maybe the most important, integrate security right into that workflow from day one. You nail these 5 things and you are well on your way. And, all of this leaves us with a really interesting question to think about. As our infrastructure becomes fully automated code, what does that mean for us, the human operators? Our role changes, doesn't it? We stop being button clickers and firefighters. We become the architects, the designers, and the guardians of these complex, automated systems. It's a pretty fundamental shift in how we work, something to chew on. Thanks for joining me.